Hi, my name is Jenna Larson, and this is my video for Lab 2 of Physics 2212, where we'll be looking at the magnetic field lines of a bar magnet. So to start off, the main purpose of our lab is to determine the dependency of magnetic fields on their distance from a magnet. And to do this, we'll be using a magnet, a magnetometer app that I have on my phone, and then just a couple yardsticks I have. And then we're going to be comparing the predicted measurements to the distance dependencies for on and off axis magnetic fields. And then lastly, we're going to simulate the magnetic field that we observed in a computer model on GlowScript. And in this model, we're going to be using some of the values that we calculated from the values we got from this experiment. And then a preview of our main results. We got a magnetic dipole moment of 5.87 ampere meters squared. And then we got an n value of negative 3.09, and then our observed versus expected magnitudes of the magnetic fields can be seen below those. And then just to get started, I've got a couple key principles that we're going to be using this experiment, such as the distant dependency formula, the Biot-Savart law, which can be used to calculate the magnetic fields, and then we're also going to be using the linearization equation, which we'll use once we start plugging all the data that we collect into our Excel spreadsheet. And then a couple assumptions that we're making in this experiment. We are assuming that the only interference we need to be aware of considering is from the Earth, and we're also assuming that the magnetometer is correctly compensating for magnetic north, and then we're also assuming that the measurements taken are accurate and that the app I downloaded on my phone actually works. And now we'll get into the fun part of the experiment. So basically we have our system is the magnetometer, or the small part within my phone, and then the surroundings is the bar magnet that I was using and everything else, aka the Earth. And then our initial conditions for setup were that the magnetometer was aligned with true north and that the bar magnet was positioned perpendicular to the phone. And once we had all this set up, we started by compensating for magnetic north, which we then used that to help us locate the magnetometer chip within my phone. And then once we got all that fun stuff set up, we measured the distances at 5 different magnetic field volumes, one at 20 microteslas, one at 70, 120, 170, and lastly one at 220. And then after that, we also used the magnetometer app to measure the off-axis magnetic field, and then using those values that we collected and put into our Excel spreadsheet, we calculated some extra values and used those to help us create a computer model in GlowScript. All right, so this brings us to the Excel spreadsheet where I added in all of my data to be analyzed. And so on the upper left-hand side of the screen is where I added in all of the distances and their respective magnetic field measurements. And then on the right side of the screen up here, we can see the lovely resulting graph with a line of best fit and the resulting equation that will come into play later. And then after this below, we can see the average distance for the off-field axis and then the average net magnetic field down here. All right, and then moving on to our coding section. Before we get started with that, there was just a couple more values that I needed to calculate and figure out before we moved on. That being the n value, the natural log of k value, and the magnetic dipole moment. And in these pictures, you can see how I calculated those and found them. And now that we have those calculated values, we can move on to our GlowScript code. And you can see I plugged in my magnetic dipole moment up here. And then down here is where I created the code or the function for the magnetic field. And then these other pictures down here is just where I created all the different arrows that we can see in the visualization that we'll get to see on the next page. All right, and this kind of brings us to the end of our coding. We can see on the left side up here, this is where I added in the perpendicular distance, and then that's kind of the only thing I had to change down here. And then on the right side of the screen, we can see the resulting visualization, as well as the big important number answers that we were looking for. All right, lastly, just a couple questions. Had we not compensated for magnetic north, the values we calculated definitely would not be correct anymore. And then had we used two identical magnets and stuck them together to create one kind of mega magnet, the strength of the magnetic field that we measured would be greater due to superposition. And then lastly, just some conclusions. We found that the closer the magnet is to the magnetometer, the stronger the field is. And then just a couple error sources, just not correctly compensating for the true north or other electronics being present. Thank you.